Good morning, my dear friends. Myself, Dr. Sanjay Singh, Professor in the Department of Mechanical Engineering, Vinayaka Mission's Kirupananda Variyar Engineering College, which is a constituent college of Vinayaka Mission's Research Foundation, deemed to be University, Salem, Tamil Nadu. So today, we are going to have a discussion on the topic aircraft propulsion. Aircraft propulsion is a very interesting topic, and most of the students, when they study this particular topic, they show very keen interest in learning the basics of aircraft propulsion, which makes them to know that how an aircraft fly and how an aircraft gets power from the engine. So especially I am going to talk about in this particular topic regarding the engine which is used in the aircraft, what are the types of engine it is used in the aircraft, and how the engine is producing power, what are the basic principles of physics applied. All those things I am going to have a discussion today. So very happy to have you here for the introduction, having the discussion on this particular topic, that is aircraft propulsion. Let me go to next slide. Fine. So you can see that as it is displayed in the slide, that what is propulsion actually. First of all, we need to know the basic meaning, word meaning of propulsion. If we are very well familiar with the word, then certainly we are in a position to explain it in a nice manner. So let us go for it. So the very first word propel, you can have a glance that propel is there. So this propel means moving forward. What we do when we go for swimming, when we pull the water towards our own side, and what happens? The water makes us to move forward. So this particular action which is taking place, moving forward, so that moving forward is called propel. Okay. And second is engine. As I told you in the beginning that we are going to have a discussion on the engine which are used in aircraft for making it mobile, for making it to move from one place to another, for making it to move at higher speed, our own desired speed. So that particular action of getting speed, which is very much necessary for producing lift force. Yes, lift force is the force which is making the aircraft to move up in the air. So lift force is very, very important. Though I have not given any basic concepts of production of lift forces through airfoil surface here, certainly in my next slide or in my next video, I will be coming with basics of aerodynamics. So that particular topic itself is different, that is aerodynamics, and in that aerodynamics I will tell you that how an airfoil surface is designed and how the airflow which is moving over the surface and under the surface is making the pressure difference, and thereby we are getting an upward force which is called lift force, and thereby the surface is moving up. So that particular topic is very vast topic that we will be having a discussion in my next video. In this video, actually, I am going to tell about aircraft propulsion, and in that propulsion, I will be telling you that what are the different types of engines are used in aircraft. I will also tell that what are the basic physics, basic principles of physics which are applied in order to make the engine work efficiently and effectively. Fine. So engine, what is an engine? So everybody wants to know that what is an engine. Of course, how can it be defined? Engine, actually, that engine word has come from conversion. So conversion of energy. So what an engine does? Engine actually is used to convert energy from one form to another. So any device, yes, gentlemen, any device which is converting energy from one form to another is called an engine. Yes, electrical motor is also called an engine. Why? Because in electrical motor, what happens? Electrical energy is getting converted into mechanical energy. Generator, yes, generator is also an engine because mechanical energy is being converted to electrical energy. Then what happens to the engine which is fitted in our two-wheeler and four-wheeler? Yes, what we do? We use petrol or diesel. Petrol or diesel, what it is? It is actually chemical energy. It is having chemical energy. So the liquid when it is burned, the chemical when it is burned, it is producing heat energy. So chemical energy is being converted into heat energy. And then further, that heat energy will be utilized to generate high amount of pressure in the cylinder. Okay, so what happened? That high amount of pressure which has developed will create the piston to move. So the heat energy is being converted to mechanical energy. So finally chemical energy is being converted to mechanical energy in the engine, or we can say that that engine is given a name that is called internal combustion engine. So internal combustion engine is having a special feature that combustion is taking place at the same place where power is utilized. Whereas we all know that external combustion engine is also there. External combustion engine means power is generated somewhere else and this power is being transferred somewhere else and the power utilization is taking place at some another place. Like a steam engine. So when the steam is being, the water is being converted into steam at one place and the steam is carried to a place where it is utilized to drive the turbine. So the place is different, utilization of power is different and generation of power is different. That's why it is given a name external combustion engine. Right, fine. So we are not going to have a more discussion on IC engines today. I told you that what is an engine? Engine is a device which converts energy from one form to another. Fine. Laws of motion. So these are some of the basics, principles of physics which will be applied extensively in this particular topic, aircraft propulsion. So laws of motion. I am going to have a full discussion on the laws of motion, that is Newton's laws of motion. Then law of thermodynamics, yes of course, as fuel is burned here. So law of thermodynamics is specifically applied. And the force which is generated, that is called thrust force. I discussed one force which is acting on an aircraft, that is lift force. I did not tell you that there are four forces. Of course, the four forces which are acting on an aircraft are, one is thrust force, another one is lift force, third one is drag force, and fourth one is weight, aircraft's weight. So in my next video, I will be giving complete detail of all those forces. Here, the engine which is used in aircraft, it is particularly used to generate a thrust force. And how a thrust force is making the aircraft to move, how Newton's laws of motion is applied, that we will see in next video. Now, we will be talking about the physics. As I told that, I will be discussing about the physics, principles of physics which are applied for that aircraft propulsion. So let us have a glance. That is Newton's first law. As I told you that Newton's laws of motion is very well applicable in generating thrust force. Newton's laws of motion is applicable in many of the places, but here in aircraft propulsion also we will be using that Newton's first law, which is also called as law of inertia. So what actually Newton's first law? So it states that every body, Newton's first law says that every body continues to be in a state of rest or in motion unless acted upon by some external force. Unless acted upon by some external force. So every object is having a tendency to maintain its state of motion or rest. That particular state of motion or rest can be changed by applying a force. The force may be balanced or unbalanced force, but here in this case, an unbalanced force only will make the state to get changed. So that is Newton's first law. Then we will go for Newton's second law. So in Newton's second law, actually it is rate of change of momentum. So what happens in Newton's second law, how the statement is that the acceleration produced in a body the acceleration produced in a body is directly proportional to the force which is creating acceleration and inversely proportional to the mass of the body. I hope you all would have understood that what Newton's second law. Newton's second law, it says that the acceleration produced by a force. So it is directly proportional to the force and inversely proportional to the mass of the body. So that particular part is being covered in Newton's second law, which is also called as rate of change of momentum. And from this rate of change of momentum, we got, as I told, that acceleration is directly proportional to the force which is applied, and acceleration is also inversely proportional to the mass of the body. By combining these two, we have got acceleration is proportional to F by m, and we can go for constant k, that is F by m, and constant k value is equal to is equal to 1, k is equal to 1. So we get F is equal to ma, and this is the basic definition of force. So F is equal to ma is the basic definition of force which has come from Newton's second law. Newton's second law. Okay. Then comes to Newton's third law, which is very much necessary, which is you can say playing a key role in producing thrust force. As I have given example of swimming in the beginning of this video, same thing I am going to have a discussion in detail now. So Newton's third law, it is related with action and reaction. What is the statement? The statement is, for every action, there is an equal and opposite reaction. Yes, for every action, there is an equal and opposite reaction. How that thrust force is making the aircraft, complete aircraft, to move forward, that I will tell you when I will be discussing about the engine. Now an example which I gave earlier also, and now also I am giving an example for swimming. Even if I am sitting on a chair, what I do? I will be applying a force on the chair, and in return, the chair also will apply force on my body. This is what? This is Newton's third law, action and reaction. When we go for swimming, what we do? We move our hand forward and then pull the water towards us. And in turn, the water is making us to move in opposite direction. Water also pushes us in opposite direction. So that is Newton's third law. Fine. Yes, now we are going to talk about thermodynamics, how thermodynamics is being used. Thermodynamics means where temperature is generated, where heat is generated. What is thermodynamics actually? Thermodynamics says about the relation of temperature or the work which we are getting it done by using internal energy or by using heat. So the relationship between heat, work and internal energy is being given by thermodynamics. So thermodynamics is very well applicable in aircraft propulsion also, because there we burn aviation turbine fuel and then only we are in a position to produce hot exhaust gases, which is moving for the rear world, driving the turbine and moving out from the nozzle and producing thrust force. So that is there. So what are the various laws of thermodynamics that we are going to discuss here? That is zeroth law. Zeroth law of thermodynamics, it is the basic, you can say, base for finding out the definition of temperature. So zeroth law is making us to know about temperature. What actually is zeroth law? How can it be stated? So this zeroth law can be stated because it is actually applicable for equilibrium, thermal equilibrium. How? It says that if two bodies, if suppose A and B are in thermal equilibrium, A and B, two bodies are there, they are in thermal equilibrium with each other. And if B and C are also in thermal equilibrium with each other, then A and C also will be in thermal equilibrium with each other. So what we saw that A and B are in thermal equilibrium and B and C are also in thermal equilibrium. Then A and C also are in thermal equilibrium automatically. So this particular thermal equilibrium is being given by zeroth law of thermodynamics, and which is the base of temperature. The base definition of temperature, we get it from zeroth law of thermodynamics. Right. Coming to first law of thermodynamics, which is energy conversion. As I have described about an engine, so engine is the device which is used for conversion of energy from one form to another. So here first law of thermodynamics, actually it is also called as law of conservation of energy. So the basic definition of first law of thermodynamics is energy can neither be created nor be destroyed. It can only be transformed from one form to another. Energy can neither be created nor be destroyed. It can only be converted from one form to another. That definition comes from first law of thermodynamics. So that's why it is called law of conservation of energy. Fine. Second law of thermodynamics, that is entropy change in the universe. So it is talking about change in entropy. Entropy is what? Entropy is degree disorderness of the reaction. So if any reaction is taking place and in that the measure of disorderness, that is called entropy. So that particular entropy change is being described by using second law of thermodynamics. So second law of thermodynamics says that in the universe, entropy is never negative. It is always increasing. It is never negative. It is not coming to zero. Even next law of thermodynamics will say about that entropy may be zero, but actually entropy is not equal to zero. Let us move to third law of thermodynamics, gentlemen. That is discussing about quantification of absolute entropy. So what it is saying that if a crystalline structure is there, crystalline structure we know that is ordered structure. So if a crystalline structure is there, in that structure at absolute 0 Kelvin, it is theoretically stated that at absolute 0 Kelvin temperature, there will be zero entropy, absolute zero entropy. So theoretically we can say that at absolute 0 Kelvin temperature, there will be absolute zero entropy, but practically there is no zero entropy. Some measure of entropy is there always. Fine. Let us move to next slide. Coming to the original topic, that is what is aircraft propulsion, gentlemen. I have shown you the figures here, piston engine and jet engine also. It is shown here. So I will be having a complete discussion on the engines of an aircraft, means all those power plants. Engine is also called as power plants. Power plants, all those power plants, type of power plants which are used in an aircraft. And then I will have a discussion on piston engine little bit, and we will go for a detailed discussion on jet engine, which is the present day scenario. Piston engines are used in small aircrafts, especially for giving training for commercial pilot license. So that type of a small aircraft, in that piston engine is used, but nowadays even turbine engine or jet engine is also used. So type of piston engine used in aircraft. So you can see this piston engine which is here. So actually the piston engines are inline engines. Inline engines means it is on the basis of, this classification is done on the basis of arrangement of cylinders. That is arrangement of cylinders. So when the cylinders are arranged in line, then it is called inline engines. Very old engines which were fitted in aircraft. Nowadays it is not used. So those engines you can say we will be finding in those aircrafts inline engines. But nowadays we do have horizontally opposed. So where one cylinder will be here in this particular point. I am showing this piston. Okay, these all are piston connecting rod, and in between crankshaft will be there. In between crankshaft, and then another cylinder will be attached to the opposite side. So the same horizontally opposed engine is being shown in this picture. You can see that one cylinder is this side, another cylinder is this side, and the crankshaft which is there in the middle. This propeller, this is called propeller, and this propeller is attached to the crankshaft directly. It is direct drive. So that is there, and the components which we are having in our IC engines, those components are only used here also, and some of the specific components which are making the aircraft to have some aerobatic moves. So for that special components are used. Otherwise for fuel supply, for spark plug, for ignition system, all those components are more or less similar which we are using in our two-wheeler and four-wheeler. Fine. Now single and double row. In olden aircrafts, we were using this single and double row, 2 rows of cylinders. So one row will be in the front and another row will be at the back. So like this arrangement of cylinders were there. So those type of arrangements nowadays it is not found. Nowadays especially horizontally opposed engines only are used. But in old aircraft sometimes we can find out. So that single 2 rows of cylinders in order to enhance more power. Then spark ignition. The engines which are used here in aircraft, that is completely SI engine, that is spark engine. No compression ignition engines are used. Yes, compression ignition engines are not used. So the fuel which is used, actually fuels used is called F gas, which is used in piston engine. And F gas is what? This is aviation gasoline. Aviation gasoline. So aviation gasoline, which is you can say more purified petrol version only, more purified petrol, having 100 octane. Having 100 octane. And specifically it is blue in color. Blue in color. So this 100 octane aviation gasoline, which is purified petrol, is used in the piston engine. So that's why it is a spark ignition engine. So spark ignition engines only are used in aircraft. Second type of fuel which is used in this jet engine. This is jet engine. So in this jet engine, it is used as ATF. ATF. ATF means aviation turbine fuel. So this ATF generally K50. K50 means K minus 50. So up to minus centigrade, this ATF in this aviation turbine fuel, there will not be any formation of ice crystals. So it will not have the minus 50 degrees centigrade, that much temperature will not have any effect on the aviation turbine fuel, and it will be continue to get supplied in the engine for continuous combustion. So that is there. Okay. Now this which I am going to talk, this is called speed regimes. So the aircraft is being operated. Aircraft is operated at different speeds. So which are those speeds in which the aircraft is traveling? So that particular part also we need to understand completely. Yes. So it is required. Now the speed regimes are subsonic. So let me first tell you that what actually is a Mach number. This M, the abbreviation M is used here, it is actually Mach number only. Mach number. So Mach number is actually, it is a dimensionless number. Dimensionless number, having no dimension. Why? So it is the ratio of speed of an object divided by speed of sound. So Mach number is equal to speed of an object divided by speed of sound, as this is the ratio of same physical quantity, speed. So that's why it is not having any dimension. So what actually is a Mach number? When the speed of any object is compared or expressed in the form of speed of sound. By comparing it with the speed of sound, then we can express it as Mach number. In the way we can use Mach number for expressing the speed of an object with respect to speed of sound. So that is with respect to speed of sound. Fine. So subsonic, the very first regime is subsonic. So when the aircraft is flying at the speed well below the speed of sound, below the speed of sound, then it will be called as subsonic, means m is less than 1. Second, transonic. So transonic is the reason when there is a change going to happen from, we can say that 0.8 Mach to 1, when the change is going to take place from subsonic to sonic or supersonic. So that particular sometimes it is going up to even 1.2, also we can say that it is transonic. Sometimes 0.8 to 1.2, this Mach number is also given a name as transonic. Transonic means when there is a change in one regime to another regime, specifically from subsonic to supersonic. Fine. Then comes to sonic. Sonic speed, when the aircraft or any object is moving at the speed of sound, that is m is equal to 1, speed of sound equal to, then only the speed will be called as sonic. Then supersonic, when the speed of aircraft is greater than 1 and less than or equal to 3.5, the speed regime is given the name as supersonic. Fine. Hypersonic, when the Mach number is greater than 3.5, then it will be called as hypersonic. Nowadays, we do have many spacecrafts which are traveling at hypersonic speeds. So after 3.5 Mach, even if it is going to 25 Mach, 26 Mach, it will be coming in the region of hypersonic speed regime. So these are the speed regimes in which the aircraft is traveling. So all the aircrafts are not traveling at all the regimes. We can say that some of the aircrafts only are in a position to travel at very, very high speed, at supersonic speed. Now, I am going to have a discussion on types of jet engines used in aircraft. As I have already discussed about types of piston engines which are used in aircraft, we did not go in detail because here jet engines are used mostly in present scenario in all commercial aircraft, in all fighter aircrafts. So all you can say the utility of the aircrafts which are there in different categories, these jet engines are used. So that's why I have brought jet engines for having a detailed discussion here. So fine, turbojet engine. So the very first engine which is used in an aircraft is turbojet engine. Now I will have a discussion on all the engines. So turbojet engine, then turboprop engine, the another type of engine which is turboprop engine, and I will tell you that if there is a word turbo, so turbo means turbine. Turbo means turbine. So that's why turbo word is also utilized here. And wherever the word prop is there, it means it is having propeller. In previous engine, when I was showing about the piston engine, I have told that what is the propeller. So propeller is just like a big fan which is fitted in front of the engine. So there in piston engine, propeller is playing a key role in producing thrust force. So as we all know, let me have a discussion on thrust force also. Thrust force. So how that thrust force is created? So F is equal to ma, we have already discussed. Now F is equal to ma, acceleration can very well be written as velocity per unit time. So this is giving you F is equal to mv by t. Now this t, if we will be taking it, so it will become mass flow rate m by t and to v, whereas m dot is equal to mass flow rate of air plus fuel, mass flow rate of air to the engine, going to the engine, plus fuel divided by time. If it is fuel, then it will become mass flow rate of fuel. If it is only air, then mass flow rate of air. Per unit time will give mass flow rate. So the force which is calculated here, which is thrust force, which I told, this is also thrust force only. So thrust force F is equal to mass flow rate into velocity. Now this thrust force can be increased by increasing mass flow rate of air which is entering into the engine, or we can also increase it by increasing velocity. So velocity, which velocity? So velocity of the gases which is going out of the engine. So that particular exhaust gases which is moving out from the engine at higher speed, that will be increasing the thrust force. So F is equal to m dot v is the real thrust force which is being generated here. Now when we use propeller, in that case, this propeller is used to capture a large mass of air. It is used to capture a large mass of air and then throw it back to the aircraft. Thereby, as Newton's third law, the reaction also will be taking place and a reactive thrust force is being created, which will be created on this propeller, and thereby as propeller is attached to the engine and as engine is attached to the aircraft, whole aircraft assembly moves forward. So in the case wherever we are using the propeller, in that propeller, mass flow rate of air is increased, whereas velocity of the gases which is moving rearward is less. But in turbojet engine, mass flow rate of air is small. Velocity of exhaust gases is higher. So in the case of turbojet engine, the exhaust gases speed is very much higher. F is equal to m dot VE. That's why we are writing m dot VE. VE means velocity of exhaust gases. So the velocity of exhaust gases used to be higher in case of turbojet engine. So their mass flow rate captured is small. So I have given a very detailed discussion and I have discussed on the thrust force completely now. Right. So I told you about turbojet engine. Then coming to turboprop engine, as I told that turbine plus propeller. Okay. Then turbofan, turbine plus one fan like structure will be there. I will have a discussion. Then turboshaft, which is utilized in helicopters specifically. So there will be a separate shaft, which will be, you can say, it will be connected with the horizontal propeller. We know that is called main rotor. So through a separate shaft will be there, and here a gearbox will be there. From this gearbox, drive will be given to the main rotor and drive will be given to the tail rotor also. So this is tail rotor. And this assembly is used in helicopter. So that's why Turboshaft engine. Ramjet engine, yes, very specific engine. we will have discussion, and then scramjet engine. So these are the engines generally used in aircrafts. Fine. Let us have a complete discussion now. So turbojet engine, as I told, we are going to have complete discussion, and I have shown the picture also here. So the very first component of an aircraft is not aircraft engine. So like suppose the engine is made in this way, fine, and it will be having compressor at this place. Then this compressor will be connected with compressor shaft, and it will be having turbine here. In between, combustion chamber will be there, combustion chamber, and this is called exhaust nozzle. Exhaust nozzle. So here the very first component of the engine, from where air will make the entry, air will be moving inside the engine. So that is called air intake. That is called air intake. So this is the first component. Yes, air intake forms the part of aircraft, not engine. So air intake is manufactured by the aircraft manufacturer. Aircraft manufacturer is different, gentlemen, and engine manufacturer is different. So engine do not consist of air intake. Air intake becomes the part of an aircraft. So aircraft manufacturer has to be in liaison with engine manufacturer, and according to the engine which is going to be fitted in that particular aircraft, air intake has to be designed. So what is the purpose of air intake? The purpose of air intake is to provide a smooth flow of air. It has to provide a smooth flow of air to the compressor. Compressor is the second component. This is compressor. Compressor. I will have discussion, and as I have make it, so this is combustion chamber. Combustion chamber. This is turbine. This is turbine, and this is exhaust nozzle, as I have written here. So now air intake will provide a smooth flow of air to the compressor. Now what is the purpose of compressor? So compressor will increase the pressure. So when the air is moving through different stages of compressor, pressure rise is taking place, and due to that increase in pressure, a high amount of pressure can be increased by utilizing several stages of compressor. Even nowadays we do have two types of compressor. Two types of compressor are utilized in a single engine. One will be called as low pressure compressor, and another one will be high pressure compressor. So low pressure compressor will be in the front, high pressure compressor will be in the rear. Similarly, we will be having two turbine, that is high pressure turbine and low pressure turbine. In this way, we can extract, if two sets of turbines are there, we can extract more work from the hot exhaust gases. Simultaneously, if more compressors are there, more stages of compressors are there, we can increase the pressure to a higher level. Fine. That is the purpose of compressor. Then combustion chamber. When the high pressure air enters the combustion chamber, then fuel will be injected by fuel supply system. We will be having here fuel nozzles. So fuel will be injected into the high pressure stream of air, and then with the help of igniter plug or spark plug, that is electrical ignition system, we will be providing a spark. Then the fuel and air mixture in the combustion chamber will get burned. Thereby, high amount of hot exhaust gases with a high kinetic energy, which is added by burning of the fuel, will move towards the turbine. And further, the gases will go and hit the turbine blades, thereby making the turbine to rotate. And in this way, turbine extracts work from the hot exhaust gases. So, after extracting, the work, the gases will be coming to the exhaust nozzle, it will move to the exhaust nozzle, and exhaust nozzle is also separately designed. So this exhaust nozzle will make the exhaust gases to leave the engine at high velocity. At high velocity. So when the gases leave the engine at high velocity, VE, and as Newton's third law, it will create a reactive force on this engine structure at the same force, with the same force, and thereby this complete engine structure which is attached with the aircraft, it will make the complete body of the aircraft to move forward. This is called thrust force, and in this way in jet engine thrust force is generated. So this all processes which are taking place inside the jet engine, it is at constant pressure. That's why the cycle which is being followed, it is called Brayton cycle. Brayton cycle. And Brayton cycle is also called as constant pressure cycle. Constant pressure cycle. So this constant pressure cycle, even if the combustion is taking place, it is taking place at constant pressure. So there are different types of combustion chambers that we will be having a discussion, different types of compressor, axial flow compressor, centrifugal compressor. So all these things we will have a discussion in my next video. Here I am going to give you a brief idea that how an aircraft works and how that aircraft generates power, aircraft engine generates power, and how it is utilized to make it to move from one place to another at very high speed. So that particular part we are going to have a discussion. What are the different types of engines are fitted, that also we are already discussing, and these are the different components. Fine. After combustion chamber, turbine is there. As I told you that the very purpose of turbine is to extract power from the hot exhaust gases. Then exhaust nozzle. Exhaust nozzle will be making the hot exhaust gases which has lost its pressure, to move or to leave the engine at very high velocity, thereby creating a high thrust force, as I told you that F is equal to m dot VE. So when VE is more, this thrust force is greater. So high amount of thrust is produced. So thrust force is the force which is created on the engine structure, and as engine structure is fitted on the aircraft body itself, so full aircraft body is moved. Yes, turbojet engine is suitable for low as well as high supersonic speed. Even for low supersonic speed and high supersonic speed, this turbojet engine is very much suitable, whereas other engines are not suitable for high supersonic speed. Supersonic speed, only turbojet engine and ramjet engine and scramjet engine will be used there. All fighter aircrafts in our Indian Air Force, we do have many fighter aircrafts. So I hope that you all would have heard about Sukhoi 30 Mark 1, then MiG-21, BIS. These are the different models of aircraft, we can say fighter aircrafts, then Mirage, then Jaguar. So these are different fighter aircrafts. Simultaneously, we do have MiG-29, we do have transport aircraft IL-76, AN-32, Dornier, we do have even basic trainer aircrafts and all. Earlier it was there, HPT-32, now it is grounded and another aircraft has taken over for giving basic training to the pilots. Fine. Let us move to next slide, that is turboprop engine. So turboprop engine, as I told that prop word is related to propeller. So we can see the propeller is there in the front of the engine. As it is turbo, so complete turbine engine, complete turbojet engine which is there, that complete turbojet engine will be used Additionally, there will be a propeller which is there in the front will be used to produce thrust force. As I told that, what is the purpose of the propeller? The purpose of propeller is to capture a large mass of air. So in this particular engine, the thrust force is generated basically by increasing the mass flow of air, and velocity of the exhaust gas is smaller in this turboprop engine. So this turboprop engine is not suitable for moving at higher speed. This turboprop engine is, we can operate it well below 0.5 Mach only. But it is much more suitable to carry heavy loads. That's why this type of aircraft, means the engines, the aircraft in which turboprop engines are used, those aircrafts are mostly cargo aircrafts. Even transport aircrafts are also there, but cargo aircrafts, in that we are having mostly turboprop engine. There will be a reduction gearbox because the propeller should not be driven at the same speed in which that engine shaft is running or the compressor shaft is running. Why? Because the propeller which is there, if it is moved or if it is rotated at higher speed more than its specified limit, then this propeller will lose its efficiency. Bending forces will be acting more on the tip of the blades, and this propeller will be completely losing its efficiency. We do not want that. That's why these type of engines are not operated at higher speeds. So that is the drawback, we can say, for the propeller. Right. Can take more load, as I told that it can take more load, and long undercarriage. Yes, due to the, you can say, a bigger propeller used to be there in the front, the aircraft needs a long undercarriage because sufficient ground clearance. There is a requirement of sufficient ground clearance. So long undercarriage is required. Less speed, it is operated well below 0.5 Mach, and it is used mostly in cargo aircrafts. Mostly it is used in cargo aircrafts. Now, next is turbofan engine. So another version of, you can say, how propeller is modified. Now the same propeller engine, we are not able to operate it more than 0.5 Mach. We want to operate the engine at relatively higher Mach. So another type of engine is designed in which there used to be a fan in the front of the compressor, and this fan will be well inside the duct, whereas we saw that in turboprop engine the propeller is well outside the duct which is enclosing the engine, outside the duct. This is the engine which is enclosed in the duct. So it was having a different limitation which has got overcome by using a fan. So a fan is inside the duct, and that fan is fitted in front of the compressor. Now this fan will be splitting the airflow which is moving to the compressor in two flows, two parts. Okay, one flow will be completely bypassing. One flow will be completely bypassing the engine, and another inflow is there which will be going to the engine, will be taking part in combustion chamber and further driving the turbine, and will be going out from the exhaust nozzle, and it will be producing thrust force. Now what about that cold flow? This is called cold flow. This is called cold flow, which are moving here. This cold flow will go and combine with the hot gases outside, and thereby it will also contribute in producing thrust force. Then what is the advantage? The advantage is less noise. Less noise. The hot gases produces more noise. So when this cold flow is going and combining with the hot gases, it will also help in reducing the noise. Simultaneously, it will also produce thrust. The aircraft can very well be operated more than 0.5 Mach. So this type of aircraft is operated up to 0.8 Mach. All transport aircrafts which we are using in our day-to-day life are fitted with this turbofan engine. Turboprop engine also are used, but those type of aircrafts are not flying at higher speed. If we want to fly at higher speed, at higher altitude, we need to have turbofan engine. How that engine is working inside the means all the flows going for combustion chamber and then extraction of power by turbine and moving out from the exhaust nozzle, that I have already explained in turbojet engine. Same principle is being followed here. Same principle. The only thing is, fan is making the airflow to get divided in two flows. One is called cold flow and one is called hot flow. Hot flow enters the engine, whereas cold flow is not entering the engine. So that's why this turbofan engine is also given a name which is called bypass engine. Bypass engine. So it is bypassing the air. Fan is there, separating the flow into cold flow and hot flow. Then it is bypassing the air. So bypassing of the engine. So that bypassing of the engine which is taking place by cold flow will maybe sometimes will be going inside the nozzle itself in some of the engines, or it will go and join the hot gases outside the engine. The effect is less noise, high amount of thrust, and high speed at 0.8 Mach also. This type of engine can be operated without losing any efficiency. Yes, of course, if the engine speed is increasing more than 0.8 Mach, the fan will lose its efficiency. Then fan will not be giving good amount of work, and then sometimes it will lose its efficiency and the total efficiency of the engine will go down. So that's why this type of engine is having limitations, speed limitations. All transport aircrafts are using turbofan engine. Next engine is turboshaft engine. Now in this turboshaft engine, as I told, that mostly it is fitted in helicopters. So in helicopters we do have horizontal rotors, that is called main rotor, which is called main rotor. The name is main rotor. It will have another tail rotor also. So another tail rotor also will be there in order to have counteract the torque which is being produced by this main rotor. If there will not be any tail rotor, this main rotor, when it starts rotating, it will make the helicopter to have a circular motion continuously. In order to have that counter effect, we need to have another tail rotor. And nowadays, in the same shaft, there will be one rotor, main rotor. There will be another rotor. Both will be moving in opposite direction. If it is moving in clockwise direction, this particular rotor will be moving in counterclockwise direction. And thereby, we can reduce that torque effect, the rotational effect, and there is no need of tail rotor. There is no need of tail rotor here in this case. So this particular two rotors are called as contra-rotating rotors. Contra-rotating rotors. So this turboshaft engine is mainly utilized in helicopters. So the construction is same as in turbojet engine. It will also have compressor, it will also have combustion chamber, it will also have turbine, and then after turbine we do have one free turbine. There will be a free turbine, free turbine. So this is called free turbine with the help of gearbox. There will be another shaft. A shaft will be driven, and that shaft will be taken to give drive to the main rotor. And again, that hot gases, it will be moving out. We can see that this is called free turbine, this is called actually gearbox. This is a gearbox and this is the free turbine. With the free turbine, with the shaft, the drive will be given to the gearbox, and from the gearbox the drive will be taken to the main rotor. From the gearbox the drive will be taken to the tail rotor also. And further, when it is moving out from the exhaust nozzle, it will be producing thrust. But this thrust which is produced by the gases which are moving out from the nozzle, it is very, very less. It is very, very less. The thrust is being produced by using this main rotor. So in this main rotor, what is there? This main rotor will make the air to move downward at higher velocity towards ground, and thereby ground will be exerting a force on this rotor blades, which is attached to the main engine, and main engine is attached to the helicopter body, thereby full helicopter body will get lifted up. Even we can change the angle of this rotor. There will be an additional shaft, as I told, and it is also called as horizontal propeller, which I am referring as main rotor, and this is for all helicopters. This turboshaft engine is used. Coming to ramjet engine. Yes, ramjet engine is very, very simple. We can have a glance. No moving components. There are no moving components. We do not have any compressor. We do not have any turbine. So very simple engine, we can say. The very simple means we can simply, it is a duct. This is a duct. So simple duct. Now on ground, this type of engine will not be working. On ground, this type of engine will not work. Then how we can use this engine? The question arises. Yes. So what happens in this type of engine? It is fitted in the aircraft in which turbojet engine is already fitted. Turbojet engine is fitted. Now let me tell that how this engine operates especially. So this engine is having specially designed air intake. Now at supersonic speed, because this type of engine can be operated only at supersonic speed, means m is greater than 1. At supersonic speed, when the air at supersonic speed enters the air intake, in the air intake some form of shocks are formed, which is called a normal shock. We do have two types of shock. One is called normal shock and another one is called oblique shock. Normal shock and oblique shock. When at supersonic speed, the air, when it is coming near to the intake of the engine, this intake will create some type of obstruction, thereby a normal shock will be produced at the air intake. Then what is the purpose of normal shock? So if this is there, the normal shock, then if the air here, it is at Mach 1 speed, after the normal shock, the speed will get reduced and the speed will be less than 1 Mach. So the supersonic speed will get reduced to subsonic speed compulsorily. Whenever that normal shock is formed, after the normal shock, the supersonic speed will get reduced to subsonic speed. Thereby, a high amount of pressure is generated inside the air intake. If high amount of pressure is generated simply only by the use of normal shock, then there is no need to have any type of compression. That's why there is no moving component. If there is no need of compressor, even turbine is also not required. And the hot exhaust gases will move to the exhaust nozzle at higher velocity, and then we will be able to get high amount of thrust. The only drawback is this type of aircraft cannot be operated on ground level, because on ground level we cannot obtain supersonic speed. So this type of air engine has to be integrated with another type of engine, which is turbojet engine. Integrated. So an aircraft which is equipped with turbojet engine, because turbojet engine only is used in supersonic speed, no other engines are used in supersonic speed. No turbofan, no turboprop, these engines are not used. Turboshaft engine especially, it is not used. Only turbojet engines are used at supersonic speed. So the aircraft which will be equipped with turbojet engine, in that aircraft only we can utilize this type of ramjet engine, where combustion is taking place at subsonic speed. Combustion is taking place at subsonic speed. The air came near to the air intake at supersonic speed. Due to the intake design, formation of normal shock has taken place, and after the normal shock, the speed has got reduced less than 1. That particular higher pressure subsonic you can say flow is entering in the combustion chamber. There, by utilizing the flame holder and fuel injector, fuel is injected and combustion is taking place. The purpose of this flame holder is to prevent any type of extinguishing of flame. It will prevent extinguishing of flame. So when the combustion of fuel will be taking place, and then directly it will be going to the nozzle. This nozzle is also specifically designed, which is called convergent, divergent. So we do have two types of nozzle. One nozzle is convergent nozzle. Convergent nozzle means the area is getting reduced, and this type of nozzle we are using in turbojet engine. Convergent nozzle. So this is convergent nozzle. And then convergent divergent nozzle. So the aircraft which is traveling, or the engine which is traveling at supersonic speeds, they use convergent divergent nozzle. So with the help of this convergent divergent nozzle, we will be able to have again Mach number more than 1, means supersonic speed can be generated. So this ramjet engine, combustion is taking place at subsonic speed. As I told, it is working only at supersonic speed. Supersonic diffuser. Diffuser is what? Air intake. Air intake is also called as diffuser. Fine. Normal shock and oblique shock. So in oblique shock, yes, I will tell in next slide, that is about scramjet engine. Fine. So I am going to have a discussion on scramjet engine now. So supersonic combustion ramjet engine. What is the full form of a scramjet engine? That is supersonic combustion ramjet engine. So it is similar to the ramjet engine, but in this case, the shock which is formed in the air intake is not normal shock, it is oblique shock. It is oblique shock. Oblique shock. Normal shock completely perpendicular at 90 degree. So this is normal shock. Whereas normal shock is not getting formed. So that's why we used to say that air intake is playing, the design of air intake is playing a very key role in making the aircraft as ramjet or scramjet, that engine. So the design of air intake. Why? Because the air intake, in that air intake only, the nose cone is there. That nose cone and the edges of the air intake will form normal shock or oblique shock. If normal shock is formed, it is ramjet engine, because compulsorily after normal shock, supersonic speed will get reduced to subsonic speed. But in case of this ramjet engine, as oblique shock is formed, so before the oblique shock, the speed of airflow, let it be suppose 3 Mach. Let it be Mach 3. Let it be Mach 3. Now after oblique shock, yes, there will be reduction of speed, but it will not be subsonic. It may reduce it to 2. We can say that sometimes m will become 2. So what happens? Before the shock, it is supersonic. After the shock, also it is supersonic. And the same supersonic speed of airflow is moving to the combustion chamber. And again in the same manner as it was there in ramjet engine, fuel is injected, it is burned, and then the exhaust gases are moving out to the convergent divergent nozzle. You can see convergent divergent nozzle and producing the thrust force. So in this particular case, in a scramjet, the combustion is taking place at supersonic speed, whereas combustion was taking place at subsonic speed in ramjet engine, which I have already discussed in previous slide. So this is the difference. That's why it is called scramjet, means supersonic combustion ramjet engine. So this type of engine needs a long body for combustion. It needs some time. So that long body where combustion is taking place, combustion chamber used to be little bit longer in this type of engine. So as I told, shock waves. So shock waves are playing major role. Here oblique shock is getting formed. Works only on supersonic speed and supersonic diffuser. The diffuser is called supersonic diffuser. Comparatively more lengthier combustion section than ramjet. So I had a full discussion on the types of engines which are used in aircraft today. I feel that our students, they would have understood and they have received a very good idea. They have got a very good idea on the various types of power plants which are used in aircrafts. I have used references for images from Google. I have downloaded for images, especially for images, and I have finished my presentation today, and very soon we will be meeting in our next video. So thank you very much.